talk about the rational root theorem and how to find all possible rational roots in any polynomial in the standard form. The rational root theorem says if we take the leading coefficient and find all factors of the leading coefficient, and also take the constant term and find all factors of the constant term, and then we do the factors of constant term over the leading coefficient term, and that will give us all possible rational roots to a polynomial. So, rational root theorem says you want to find factors of p because p is your constant term, and you want to find factors of q, which is your leading coefficient term. So, let's try that. So, factors of p will be plus and minus 1, plus and minus 5. Because those are the only factors of 5. If you want to take factors of q, plus and minus 1, and plus and minus 2. So, the possible rational roots are in the form of x equals plus or minus p over q. So we need to take all possible combinations of p over q. So I'm going to take plus and minus 1 over 1, plus and minus 1 over 2, plus or minus 5 over 1, plus or minus 5 over 2. So these are all possible roots to the polynomial 2x to the third minus x squared plus 2x plus 5 equals 0. Now, to actually find the possible rational roots, remember rational means it's either a fraction or a decimal. It's also a whole number. In other words, it has to be a number that can be put into a fraction. Square root 2 is not a rational, that's irrational. So, step 4 is we want to guess and check the possible roots. So we want to take x can equal any one of these 8 combinations. So you want to substitute your values for x and see which value makes it 0. So let's check positive 1. So if we have 2, 1 to the third minus 1 squared plus 2 to the 1 plus 5, does that equal 0? And it does not. That is no. So positive 1 is not a root. There's a much easier way to do this. You plug in the equation into y1 in your graphing calculator. So let's do that. So we're going to our graphing calculator and we're going to enter the equation 2x to the third minus x squared plus 2x plus 5. And we want to do the guess and check. So now we're going to hit second trace and we want to find value. It's going to graph it. Use the graph to distinguish, okay, I have no positive roots. No positive roots. So we know that our solutions must be negative, so we're not going to use any positive roots. So let's check the other possible roots. Let's check negative 5/2. Let's check x equals negative 5/2. So we're going to put in negative 5/2. And we're looking for 0 where it says y equals, and we don't get 0. So negative 5/2 is not a root. So, no. So now let's check negative 5. So, negative 5. And you notice that y equals negative 280. We want y equals 0 when it's negative 5. So negative 5 is not a root. So let's check negative 1/2. And we don't get 0. So, not a root. And let's check negative 1. And we do get it 0. So this is our only rational root, negative 1. So negative 1 does make a root. So the only rational root is negative 1. That is the rational root theorem. I will do another video with a different example.